Question 26, we've got our particle being held in equilibrium by these three forces. And of course, this one's going up at an angle. So much like all of this second year stuff, we've got to use these angles. The force going up here is P cos alpha, because it's next to the angle. And the force going away from it to the right there is going to be P sine alpha. Now we've also got a force here pulling to the right with 6 and down with 15. And if it's in equilibrium, these must all be equal to each other. So we must have P sine alpha equals 6 and P cos alpha must equal 15. We're asked to find out what alpha is. So I'm going to divide these two equations. The p's are going to cancel out and I'm going to get a tan alpha, because sine divided by cos is tan. Tan alpha is 6 over 15. And if I do the inverse tan of that, that tells me alpha is 28.1 degrees. Once you know that alpha's 28.1 degrees, of course you can just tap that in now. P times the sine of 21 equals 6. And so P equals 16.2, doesn't it? Just doing 6 divided by the sine of 21.6. The force P is removed. So if it's removed, all we're being left. So, I mean, really, look, this force here is 16.2. That means the balancing force must be 16.2 that way as well. And so when this one's removed, I've just got a force of 16.2 going off like that. And force equals mass times acceleration. 16.2. Finally, you get your mass in here. You were wondering why it told you that the mass was 3. So it tells us that our acceleration here is 5.39. It starts at rest. I get it was held in equilibrium, wasn't it? U equals 0. V I don't care about. S is how long we want to go to take 10 meters. A is 5.39 and T is what I'm trying to find out. So what should we use? An S equals UT plus half AT squared. 10 equals 0 plus a half times 5.39 T squared. And so T is the square root of 20 over 5.39. And I've got 1.93. You can see that, 1.93 down the bottom there.